Permutation is an ordered arrangement of R objects taken from n number of objects. So a permutation is an ordered arrangement of objects. So there are four types of permutations. The first one is the distinct permutation with repetitions. We also have the distinct permutations without repetitions. The third one is the circular permutations, and the last one is the non-distinct permutation. So in this lesson, we are going to discuss all of the four types of permutations. Let's first talk about the distinct permutation with repetitions. So for this permutation, there are n number of distinct objects. When we say distinct, each object is unique, and you're going to choose r number of objects to arrange, and repetitions are allowed. Now, when we have a distinct permutation with repetitions, we use the formula n raised to r, where n is the total number of objects and r is the number of selected objects. So let's have an example when we can apply the distinct permutation with repetitions. For example, you are creating a 5-letter password for your email account and repetitions of letters are allowed. The question is, how many possible passwords can be formed? Now we have to determine first the value of n and r. Obviously, the value of r is equal to 5 because we are going to choose 5 letters to make our password. Now, what is the number or what is the total number or what is the value of n? The value of n is equal to 26. Why? Because we have 26 letters in the alphabet and we have to choose 5 letters to create our password. Therefore, if we have the formula n raised to r, we can find the number of possible passwords by simplifying or evaluating 26 raised to 5, and that is equal to 11,881,376. Therefore, we have 11,881,376 possible passwords. So that is how you apply the distinct permutation with repetitions. For the next type, we have the distinct without repetitions. In this case, we have n number of distinct objects. Again, each object is unique. And you're going to choose r number of objects to arrange, and objects cannot be repeated. That's why we have without repetitions. Now, if we have the distinct number of objects without repetitions, the formula is NPR is equal to n factorial all over n minus r factorial. Now, the symbol for the distinct permutation without repetitions is NPR. Again, n is the total number of objects and r is the number of selected objects. Let's have an example for a distinct permutation without repetition. Like for example, we have a club with 8 members will elect their officers. The question is, in how many ways can they choose a president, a vice president, a secretary, and a treasurer? Now this time, this is a distinct permutation without repetition because we have to choose only one person for each office. Now we have to determine the value of n, which is equal to 8 because we have 8 members in the club. Now what is the value of r? The value of r is equal to 4 because we have to choose a president, a vice president, a secretary, and a treasurer. So we can now use the formula for the distinct permutation without repetition, which is again, NPR is equal to n factorial all over n minus r factorial. So we have 8p4 is equal to 8 factorial all over 8 minus 4 factorial. Now again, to get 8 factorial, we just have to multiply 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So 8 factorial is equal to 40,320 all over 8 minus 4, that is 4, factorial, that is 24. So 8p4 is equal to 40,320 divided by 24, and that is equal to 1,680. Therefore, we can choose a president, a vice president, a secretary, and a treasurer in 1,680 ways. The third type of permutation, we have the circular permutation. So in a circular permutation, n objects can be arranged in n minus 1 factorial ways. So from the word itself, the objects are arranged in a circle. For example, Marion has 5 candles, each with different color. Again, we have distinct objects. The question is, in how many ways can he arrange the candles around a cake? So the word around means we have to arrange it in circular arrangement. Therefore, we can use n minus 1 factorial. And obviously, the value of n is 5. So we have 5 minus 1 factorial. Therefore, we have 4 factorial, or it is equal to 24. Therefore, there are 24 ways that we can arrange, or he can arrange the candles around the cake. So that is circular permutation. For the last type of permutation, we have the non-distinct permutation. So there are some duplicates in n objects, and you use them all in your arrangement. So this time it is non-distinct. Therefore, we have some duplicates. And the formula for this is n factorial all over n sub 1 factorial, n sub 2 factorial, up to n sub k factorial, where n is again the total number of objects, and n sub 1, n sub 2, up to n sub k are the duplicated objects. So how can we apply the non-distinct permutation? For example, we have, in how many ways can you arrange the letters of the word biology? So as you can see, we have 7 letters in total. We have B, I, O, L, O, G, Y. And we have some duplicates. As you can notice, we have 2 O's. Therefore, this is a non-distinct permutation. So how can we use the formula for the non-distinct permutation? Again, n is the total number of objects. Therefore, that is 7 factorial. All over what? So we have 7 factorial all over 2 factorial, because we have 2 O's. So that is equal to 7 factorial is equal to 5,040, and 2 factorial is equal to 2. So we have 5,040 divided by 2, that is equal to 2,520. Therefore, we have 2,520 ways to arrange the letters in the word biology.